Thank you. Good morning. On behalf of Mark Weber and the rest of the public sector team at NetApp, welcome. I'm curious. I can kind of see some of you. How many of you were around for the earthquake on August 23rd? You remember where you were at? Yeah, I was actually at the convention center hosting an IT panel at an event called, and I kid you not, Shake IT Up, Shake It Up, right? You can't make this up, right? I mean, it's true. Well, today, and I want to talk to you about a different, what I call tectonic shift. This one's not driven by seismic activity. It's driven more by technology and what's happening with big data, as you heard. So, and this is one shift that is definitely going to shake up traditional enterprise applications as well as the IT organizations that manage them. So, very interesting. This is being driven by a world explosion in data consumption. You heard Dr. McClure talk about big data, and I think you probably heard other people talk about big data. Well, this is what's behind it. As of 2010, the world consumption of data passed 1.2 zettabytes for the first time ever. Okay? Now, that was the data rate was growing at about a factor of 9 over 5 years. Now, if you don't know what 1.2 zettabytes looks like, Wikibon has this great graphic that you see behind me. Picture taking 75 billion iPads fully loaded with data and stacking them end to end, side to side, and then on top of one another until it reaches a column over 4 miles high. That's what 1.2 zettabytes looks like. And this year, it's about to go over 1.8 and continue from there on. The real scary thing about it is most of this data, though, is unstructured data. And it's rich media data, very high-resolution graphics, very high-resolution video, and so forth. And a lot of it is actually machine-generated. So for example, when you email a message and you have an attachment, and if that email package doesn't have single instancing and you send it to 50 people, all of a sudden the machine generates a bunch of extra data, right? Or if you go on to Facebook and you load on a picture or you start talking with your friends, the machine generates a lot more data than what you load up personally. So that's pretty amazing. 90% unstructured data. Well, cheer up. It's going to get worse. Okay? IDC projects that over the next decade, while servers will be growing, and this includes both physical and virtual machine servers, by about a factor of 10, data is actually going to grow by a factor of 50. And the numbers of files that make up that data are going to grow by a factor of 75. As a storage provider, which NetApp does enterprise storage, if you didn't know what we do, how are we going to protect all that stuff and move it where it needs to be? And also another little tidbit is, sadly, over that time, you notice IT professionals are only going to go up by 50%, what's projected, and budget's going to be pretty flat. That's kind of scary. And what makes matters worse is that it's already bad today because organizations don't know what to throw away and what to keep. We've become pack rats. And it's going to get even worse now that data's coming in at an even higher rate. And so that's going to put a lot of strain on IT organizations. It's also going to put a lot of strain, frankly, on the technology vendors like NetApp and EMC and the other storage vendors and other application vendors and so forth. And it's the latter one. It's the application vendors I want to focus in on a little bit as we look at as we continue on here. So the Earth, I would argue, is beginning to shift beneath traditional applications in businesses, the Oracle databases, the Teradata databases, the CRM tools, and things like that. All of a sudden, all this data coming in is causing the Earth to shift out from underneath them. And I would argue that it already has, to a large degree, shifted and the foundations are already cracked. What you see behind me, in a way to explain this, I got a graph where on the bottom is a graph of performance, where on the far right is extreme small block random I/O performance, hundreds of thousands of IOPS a second. And on the left, large block sequential I/O. Both of these are very challenging, and in between is a mix. And what I've done, and on the vertical axis, I have a measure of data structure. So if it's high data structure, it's something that's in a traditional database. If it's low data structure, it's just a bunch of dissociated files in an archive, or that's what we traditionally think of things. So I've endeavored to plot some of the more common workloads on this graph, and interestingly enough, most of the traditional business applications are in this green area here, this green zone, and they're the things you think of. I mentioned them before, like Oracle databases, for example, or SQL Server databases. And they're comprised of, they're built assuming that you already know what the question is, the business question or the mission question you're trying to answer. So a DBA, dutifully goes through, creates a schema, and then they begin loading data in, and then you get to use it, and this thing answers the question that you knew about faster and faster and faster. Okay? Interestingly enough, the infrastructure underneath that is an infrastructure that's finely tuned, as you can see there, for mostly small block random I/O. Now, over the past several years, you've seen a big shift in the way we do infrastructure driven by server virtualization. And so now, more and more of these things are being done on shared virtualized infrastructure, and we're paying attention to integrated data protection and how I put people on a shared multi-tenant environment, because people don't like to share things, right? And so we're figuring out how to do that. And so infrastructure has changed dramatically over how it was done in the past, but the applications themselves, like the Oracle databases, SQL Server, things like that, have remained pretty much untouched. But that's beginning to change now with all the data coming in. So when I talked about all the big data coming in, that's more in the blue zone area here. This big data, high bandwidth, high resolution, more sequential in nature, and as you can see, it's orthogonal to this market defined by the green zone. And it has some very interesting implications on the database applications and so forth. So first of all, what are they? Well, once again, I got a lot of unstructured data, and it's rich media. Well, unstructured data resists being stuffed into a very structured database. Just doesn't like it, doesn't work. And as it becomes bigger, and as the objects become bigger and bigger, you can see for a time a lot of the database vendors were figuring out how to put objects in their relational databases. Well, Microsoft recently just gave up on that. They couldn't, and so now they're just sticking these objects out on a CIF share, and the metadata stays in the database, and now you have to access it in two ways. I have to go at it with a block I/O and a file I/O protocol, which is great for NetApp. I mean, we do unified architecture, but it's just a different way of doing things. Increasingly, I mentioned to you also that the numbers of files are going to increase. This is going to put a strain on the file systems beneath those databases, because we have these things called inodes that point to all the blocks in the data, and we're running out of them. File systems can't handle it, and all of a sudden you're stuck with having to all of a sudden multiply instances of these file systems, which becomes a big management nightmare. To get around that, what you're seeing is more and more some of the storage vendors, you're going to see more and more use of object-oriented storage to actually take and package a lot of those files into bigger containers, which are self-describing objects. And then lastly, the underlying storage that runs this data has to move from stuff that's optimized for small block random I/O to racehorses in sequential I/O, where it could be 10 or hundreds of gigabytes a second of throughput, and that's no small feat. These storage arrays will use more and more less expensive high-capacity drives, and they'll have some type of flash tier in there to help with the small block random I/O. And so you already begin to see the shift in behavior in your storage vendors you deal with, right? I mean, EMC, who did they buy recently? Go ahead, you can shout it out. Isilon, right? You're seeing more scale out and more sequential throughput systems. EMC bought Isilon, HP bought 3PAR, Dell bought Compellent, NetApp actually bought two companies. We bought one called Bicast, which did PAX data, big objects, PAX data, and we also bought Ingenio. So Very, very challenging, okay? So that's part of it, but as the data goes, so goes the metadata. In the past, you know, you could use things like Teradata and so forth. Now, that's not the case. You find more and more with unstructured data, you find a lot of companies beginning to use things like Hadoop to drive what they're doing. So we're seeing more and more that new companies are coming on every day, and they're doing analytics, fast analytics, because I want to be able to search through all that data, and I want to get to knowledge, and I want to get to actionable intel and things of that nature very quickly. So you're seeing companies come up that are not only SQL databases like MongoDB, Cassandra, HBase. You're seeing columnar databases like Parexel, and these guys are processing analytics 100 times faster than the traditional guys at a fraction of the cost. And you see a knee-jerk reaction in the traditional guys as they're all scrambling to have a Hadoop offering, but ironically, they're only really using it for extraction, translation, and loading. They still have their relational database behind it, so don't be fooled by that. So what's going to happen? I think what's going to happen with all this data coming in that's unstructured is extraction, translation, and load, or ETL, is probably going to go away. When you stored the data, that was your ETL. And now you're going to process it in place. All this data is also going to drive up what's going to be needed in terms of rack densities. You're going to want to pack in more per rack because the data centers are fixed. It's going to drive up more thermal. It's going to drive up more floor loading and everything else. So the nice thing about it is that we see a fairly mature market and a growing market in data center containers. So for example, you see a picture of a 20-foot one there from one of our partners, WWT. This little 20-foot thing can pack in about 9 petabytes of data and about 1,000 cores of information and greater than 15 kilowatts a rack. So what we find is agencies who are constrained either economically or by law in having a fixed number of buildings are beginning to use these things and move their servers and their compute farms into them, and then they're repurposing what were data centers for office space so they don't have to build either new. And I think this is a good idea. These things are very efficient. They use power utilization efficiencies of about 1.2. Lastly, you can't talk about what's going on in big data without talking about the network. And data is growing by a factor of 50, but if you look at Ethernet, and Ethernet's been on a relentless march. I mean, everything that's ever competed against it has been niched, right? Remember Token Ring? Remember, FDDI, ATM, things like that. It's continuing, but it's only growing by factors of 10. And the ramifications of this are you may find you have to make a decision with all this data coming in. I'm either going to process it where it lives, or I'm going to move it and protect it someplace. I probably won't have the bandwidth to do both. Or I'm going to have to throw stuff away. So, in conclusion here, the so what's I want you to take away from this are things are now beginning to change for the application. There's going to be an increased tendency towards distributed repository because of the limited bandwidth. So once again, people are going to want to access and exploit data right where it lives. You're going to get these communities of interest. And think of these distributed repositories where fast analytics is like the metadata layer that glues them all together. Metadata management we talked about is going to put strain on traditional apps, and so I think you're going to see an uptake of MapReduce and Hadoop and things like that in new application, and you're going to see a lot of the traditional applications get kicked more to the curb. In terms of data management, so you have the metadata layer, the actual big objects in the data management layer and the storage and so forth. I think you're going to see more use of object storage with Cloud Data Management Initiative there for access. And then lastly, you're going to see a lot denser configurations probably in these containers to allow you to have higher thermal densities and allow you to have heavier floor loading and actually to have a degree of mobility. So I hope that's useful. I appreciate your attention. And if you have any questions, I'd be happy to talk to you afterwards. Thank you.